In 2008, ADIF awarded the joint venture formed by Alstom, Isolux, Elencor and Electren the contract for the design, supply, erection, testing, commissioning and maintenance of electrical substations, auto transformation centres and their SCADA for the Madrid-Valencia-Albacete railway line. The complexity of these 46 installations, which include 8 substations, 30 intermediate auto transformation centres and 8 final auto transformation centres, clearly demonstrate ADIF's faith in these companies, which were responsible for the substations on the Madrid-Barcelona and Córdoba-Málaga high-speed lines. The Madrid-Valencia line starts in Atocha station, extending south to Torrejón de Velazco, where the final substation is located. From this point on, the line continues towards Cuenca and Montilla de Palancar, where it splits into 2 branch lines, one leading to Albacete and the other to Valencia. Santa Cruz de la Zarza substation. These substations provide an electrical power supply with a voltage of 25 kilowatts. After the relevant environmental and geotechnical reports and archaeological supervision, each of the electrical traction substations will be built on a leveled, compacted platform. The high-tension equipment and the control building will be located on these platforms. Each substation will connect to the Spanish main power grid via high-voltage lines, 400 kilowatts. 2 60 megavolt ampere transformers will be used to reduce the 400 kilowatts to a voltage of 2 times 25 kilowatts. This is a pioneering system developed by these 4 companies for the Madrid-Barcelona high-speed line, which minimizes energy loss and reduces electromagnetic disturbance, allowing the substations to be spaced up to 60 kilometers apart and thus making the system more efficient and cost-effective. The built-in redundancy of the system ensures an uninterrupted passenger service in all situations. The control building contains 2 by 25 kilowatt voltage level equipment plus auxiliary equipment. It's also worth mentioning the modern built-in distributed control and protection system, which allows individual items of equipment to be managed both locally or remotely using energy SCADA. Outside there are overhead contact line output lines, which carry 2 by 25 kilowatt to the train power lines, and the negative feeder typically used in the 2 by 25 system. Ocaña, end auto transformer station. A final auto transformation center is located between every 2 substations. This miniaturized substation is a fundamental element in the 2 by 25 system and has a dual purpose. On the one hand, it recovers the energy which comes from the substation via the negative feeder, which is fed into the overhead contact line and then to the train, hence reducing catenary voltage drop. On the other hand, if a substation fails, it can be used to power the collateral overhead contact line electrical section. Intermediary auto transformer station. The function of the intermediary auto transformer station is to recover the energy which comes from the substation via the negative feeder and feed it into the overhead contact line. Current progress. The works began in May 2008. In February 2010, the Minganlilla area was powered, and electrical trains being tested started to run between Albacete and Montilla de Palancar. In February and March, the first auto transformation center entered into service, along with Las Avenas and Villanueva de los Escuderos substations. The remaining substations have been progressively added. After having successfully finished these large works, the line entered into service in December 2010. The importance of this project is clearly demonstrated by the following figures. 46 installations built on more than 400 kilometers of high-speed railway line, more than 500,000 cubic meters of earthworks, 6,000 square meters of industrial buildings, 16 60 megavolt ampere, 92 15 megavolt ampere auto transformers, all in a record time, from May 2008 to December 2010, and without having suffered any occupational accidents, despite the dimensions of the works. This project firmly establishes Isolux, Alstom, Electren and Elencor at the technological forefront of the railway sector.